Hi guys, in this video we're going to be discussing speed and stopping distance, thinking distance, braking distance, stopping distance speed graphs, estimating distances, and then we'll finish with a summary.
To understand the relationship between speed and stopping distance, we're first going to need to break down stopping distance into its two parts. It can be broken down into the thinking distance and the braking distance. So for example, if we use this orange line to represent the whole stopping distance, that is the distance it takes for a car to come to a halt, then this distance can be broken down into the thinking distance and the braking distance. And we're going to want to know separately how the thinking distance and braking distance depend on the speed of the car. And in particular, whilst we know that the thinking distance and braking distance are going to depend on how fast this vehicle is moving, we would like to know which of the two distances is affected the most by the speed. So what we're asking is, if we increase the velocity of a car from 60 miles an hour to 90 miles an hour, then which distance will increase more? The distance we travel while we're thinking, or the distance we travel once we've put the brakes on? Let's start by thinking about the relationship between the thinking distance and speed. Now, one thing to note at this point is that distance and speed are quantities which are directly proportional. And we know this from the equation. Distance is equal to the speed multiplied by the time. Now, the thinking distance is the distance we travel during the thinking time. Now, this thinking time is something which is fixed. It's the time it would take us to realise we need to brake. And so what this equation tells us is that the distance is proportional to the velocity. That is, the distance we travel while we're thinking is proportional to the velocity that the car is moving at. Now, during this thinking time or reaction time, we have not yet applied the brakes, so we must continue at the same speed. There has been no net force on the car. So here is our car, which during the reaction time...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the SnapRevise smiley face. Join me today and let's make physics at GCSE a walk in the park.